Welcome to Diwakar Physics. In this video, we'll learn all the questions that asked in 2023 Icse exam. So, all the questions from 2023 Icse exams will be discussed. So, you can follow this video till the end. So, here is the first MCQ. Which of the following radiations suffer maximum deflection in a magnetic field? So, alpha, beta, gamma and X-rays. The maximum deflection is shown by the beta particle. Okay, maximum deflection, it has very low mass, that's why it is deflected quickly. Now second question is the subjective question. When does the nucleus of an atom tend to become radioactive? Okay, when does the nucleus become radioactive or unstable? So that is the question. The answer is when the number of neutrons in the nucleus of the atom is much more than the number of protons. Okay, usually in the atoms with low atomic number, they have equal number of protons and neutrons. But when the number of neutrons is much more than the number of protons, then the atom, the nucleus becomes radioactive. So this is the answer. Okay, so now we'll go to next question. How is the radioactivity of a radioisotope affected if it undergoes a chemical change? So iska first answer is, how is the radioactivity affected? The radioactivity is not affected. Okay, the radioactivity is not affected by the chemical change because radioactivity is a nuclear phenomena. Okay, it's a nuclear change. So the nucleus of an atom takes part in the radioactivity and not the orbital electrons. So in chemical change, orbital electrons take part, but in the radioactivity, nucleus takes part. So that's why whenever there is chemical change going on, that is dealing with the orbital electrons, so radioactivity does not change. So it will show the same behavior even if it is oxidized, okay, reduced, and other chemical processes are taking place with the radioactive sample. So that's why, so you have to write nuclear phenomena and chemical change takes place with the orbital electrons, but radioactivity is involved with the nucleus. So this is the answer. Okay, so next question was to complete the change or equation, nuclear equation. Now here the question was like this. An atom P with atomic number 92, mass number 238 is changing to Q with the release of helium, that is related to, that is alpha particle. Okay, so alpha particle is released here. So then you have to write the atomic number of Q and mass number of Q. So when alpha particle is released, then alpha particle is the packet of 2 neutron and 2 proton. Okay, so when alpha particle is released, then 2 protons are released, 2 neutrons are released. So if you consider this 92, this is basically the number of protons. So that means if 2 protons are going out, then here it will be 92 minus 2, that is 90. Okay, so when alpha particles are emitted, reduce the atomic number by 2 because 2 protons are going out. Okay, what about the atomic mass number? So here you see the mass number is the number of protons plus neutrons, and altogether how many are going out? 4. 2 protons, 2 neutrons. So obviously from 238 4 will be subtracted. So 234. Now it further gives beta particle electrons. As electron is released along with the formation of R. So when electrons or beta particles are released, then atomic number increases by 1. So 91, because there is the change of neutron into neutron will change into proton and electron. So proton is added in the nucleus and this electron will be thrown out in the form of beta particle. Hence, the number of protons increasing by 1. So 91, and 1 neutron is decreasing, 1 proton is forming. So that's why mass number remains the same. So 234 will remain 234. So this way you can write. So next question was, name the nuclear radiation which has the highest ionizing power. So alpha particles or alpha radiation. So alpha radiation have this +2 charge, that's why they have the highest ionizing power. That means whenever they pass through a medium, then these alpha particles will change some molecules of the medium or atoms of the medium into ions due to the +2 charge. So next question asked was which nuclear radiation will travel undeviated in an electric field? So answer is gamma radiation. So gamma radiations do not have electric charge, so that's why they are not affected by electric field, hence they go undeviated. So gamma radiation. So in magnetic field also gamma radiations go undeviated. So last question. So the next question 7. How can one stop the radiations escaping from a nuclear reactor in a nuclear power plant? The answer is the nuclear reactor is shielded with lead and steel walls. So steel walls are taken and lined with the lead. So lead absorbs this radiations alpha, beta, gamma. So that's why this shielded with lead and steel walls. So it will stop the escaping of of any radiations from a nuclear reactor. Okay. So next, name one internal source of background radiation. So internal source which is present right in our body, you can write. So potassium 40. Yeah. This is K40. Okay. So it is present in our blood. So that's why it is the internal source, and we always are exposed to this radiations sent by the sources. So we have no control over it, but their effect is very less. So that's why they are called background radiation. These are not direct sources, but present in our body or around us. So that's why this is the answer. You can write carbon 14 also. Okay. So these 8 questions were asked in 2023 and total of 10 marks. Okay, in the section 1. So section 1 compulsory part, 4 marks questions were asked, and in section B 6 marks. Now if you see this pattern of question, then 3 marks are asked with the sound. Okay, so with sound, that means radioactivity and sound. So and 3 marks out of the 6 are asked with the electricity. So that way they have combined the questions from radioactivity. So accordingly you can prepare. But this chapter is good. 10 marks questions are coming from this chapter.